All right, friends, hello, welcome back. This is our second lecture in topic 2, and we're going to be covering today another model, a real classic, a really important, a real simple, but a powerful model in economics that's called the PPF, the Production Possibilities Frontier Model. Okay, I always like to break down jargon, so before we get into the nitty-gritty of this model, let's take some of these terms and break them down. Production is obviously what is being produced or made. Possibility obviously implies what's your ability, what you're able. And frontier can be seen as like a border or a limit. So before we even get to the nitty-gritty, let's kind of rethink about this thing. The production possibility frontier model, it's a model that shows the limits of how much stuff a society is able to make, okay? So we're gonna look at this model through the lens of scarcity and the lens of trade-off, but at its core, the production possibility model simply illustrates trade-offs because it illustrates the limits of what an economy can produce, okay? So if you take a look at it, you see right here that we have the model here. The PPF is an economic model, which we said, that shows the limit of what an economy can produce when all resources, and this is the key, are used efficiently. The PPF shows the limit of what an economy can produce when all resources are used efficiently. Now, this model is very simple, but there's a couple of assumptions that drive it. Assumption number 1, the PPF model assumes that an economy has a fixed amount of productive resources. That the economy does not have unlimited land, labor, capital, but that scarcity plays in, and that at a given moment, an economy is constrained by a fixed amount of productive resources. The second assumption says that there is a fixed amount of technology. And specifically of technological resources and know-how, so of technical knowledge. So the PPF assumes that number 1, the economy in question has limited a set limit of resources as well as a set limit of technology and technical knowledge. And number 3, and this is just to make the model work from the ceteris paribus assumption, we're going to assume that only 2 goods are produced. Now, a lot of times people will say that makes the model less valid, but in fact, it actually makes it even cleaner because it allows you to look at the impact. Oftentimes, when you look at PPF models, the 2 items that are made tend to have some sort of metaphorical kind of significance. You know, it used to be they would have like guns and butter, and that was like, you know, military production and civilian production, or things that enhance life and things that destroyed life, right? And the trade-off involved. Often today, what you'll see, like on this one, are televisions and turbines. You'll see a consumer good and a capital good. You know, a good that you consume right now versus a good that you make to consume and build for the future. And that shows the trade-off between immediate consumption and long-term consumption, okay? But again, our model assumes that there's going to be a fixed amount of productive resources, a fixed amount of technology and technical knowledge, and that only 2 goods are produced. If you take a look up here at the model, you can identify that points A, B, C, and D are on the border. Look at point A. Point A is a far extreme. Point A implies that the economy is going to make 6 televisions but 0 wind turbines. We're right here, and that's 6 TVs and 0 wind turbines. Okay? Point A, in other words, is the economy deciding to allocate all resources toward television production. Look at point D down here. At point D, the economy is saying, we want no TVs. We're going to allocate all resources to wind turbines. and they can make 3 wind turbines if they make 0 TVs. So typically on a PPF curve, you're going to have the 2 extremes, and then you're going to have a bunch of points in the middle that represent trade-offs of those extremes. In this case, point B and point C. Point B, it's still on the line. Because it's on the line, it's on the limit, it still implies the full use of resources. But it implies that you're giving up one thing to gain a bit of the other. If you look, going from point A to point B, you're going from 0 wind turbines to 1, and you're going from 6 TVs down to 5. So the movement from point A to point B, again, point B is still efficient. It's still on the limit, which implies that it's using all of the available resources and technology. It's simply saying we want to have a mix of products, okay? So that's what that is. If you take a look at all that, what you would see is that you're going to have points along the PPF, inside the PPF, and outside or beyond the PPF. Each of these points has some significance in terms of the use of resources and if it's efficient or not. So briefly, we would say that any point along the PPF is both efficient and, at least in theory, attainable. It's efficient because you're operating on the line, which means, as our model said, as our assumption said, you're using full resources productively, okay? It's attainable because, in theory, you can get there. Now, in the reality, no economy ever reaches their PPF, pardon me. No economy reaches their PPF, but it's still worth striving toward. It's an idealized state that if an economy can get to, makes them better. It's one of those. It's like a goal that you set for yourself, a stretch goal. You may never get it, but that's okay because just the act of striving toward it improves you. Economies will never reach the PPF. But the act of striving and taking the policy steps to move toward it benefits everybody, okay? So again, points along the PPF are efficient and attainable. Points that are inside the PPF are attainable, but inefficient. In this case, we're talking about point R, or let's just put a point here. We'll call this point X. That's way inside the PPF. Well, if you know that you could make a lot more wind turbines and a lot more televisions, that means that your current level of production is not efficient. It's inefficient. You're not using the available resources or technology to their fullest potential limit. There's lots of things that will cause an economy to operate within its PPF. Bad policies that stifle employment, not maintaining infrastructure so that roads and factories and those things aren't fully at capacity, a workforce that's not getting training. There's lots of things that can do it, okay? But again, by definition, we say that points along the PPF are efficient and attainable, that points inside the PPF are attainable but inefficient. And we say that, at least for the current moment, points beyond the PPF are unattainable. That right here is point Y. Point Y is currently not attainable. By definition, if it's beyond the border, if it's beyond the limit, if it's beyond the PPF line, it's impossible because the PPF line is the limit of what you can produce given existing resources and technology. You cannot produce past it. So at least for right now, point Y, impossible, okay? Now, the PPF, there's a lot going on with it. It's very big on the ideas of efficiency. We've talked up here that, some points are efficient, some points are inefficient, but efficiency is a big part of this model. When we talk about efficiency in economics, we can break it up into 2 different types. We strive for both, but they have subtly different meanings. So let's jump into those real quick. The first type of efficiency that we look at is what's called productive efficiency. And productive efficiency is defined as obtaining the maximum possible output with a given set of resources, or, seen a different way, obtaining output for the lowest possible cost. Okay? Productive efficiency, let's just turn that around, efficiency in the act of production, implies that you're either getting the maximum amount possible with a given set of resources, or, saying the same thing differently, you're producing your output for the lowest possible cost. This is a really, really big goal in economics. We know that resources are scarce. So operating at productive efficiency means that you're making the best use of those scarce resources. And therefore, you're able to stretch those scarce resources and get as much output as possible. And we learned before, it's that output that brings people utility through win-win trade. So it all comes together there, okay? Allocative efficiency, on the other hand, is not so much about the productive angle, but about the distribution angle. Allocative efficiency is defined as obtaining maximum well-being by producing what we're going to call the right set of goods and services. Okay? Now, right set is going to be a normative statement. And it's oftentimes up to a population to use the political process to determine what that right set is. Maybe the economy, maybe the citizens want more education and less military, or more healthcare and less something else, okay? Productive efficiency simply says we're making the most possible stuff given the scarcity that we face. Allocated is saying we're distributing it in the way that maximizes well-being. To put this in context, on the PPF curve, you can think any point on the curve is productive. Allocative efficiency is deciding if A or B or C or D or some other combination or point is correct. Okay? Note that A, B, C, and D all represent productive efficiency because you're at the limit. Allocative is when society says, this is the mix of output that we want. This is the trade-offs that we're willing to make. Okay, so that's the two types of efficiency. The final thing about the PPF model is in terms of the visuals of it, you see that there's a slope in the PPF. And the slope, as you may have guessed, illustrates opportunity costs. The slope of the PPF illustrates opportunity costs. Let's go back up here again, and let me try to clean this up a bit so that we can make some sense of it. You know, let's say, for example, that we are starting off at point A. At point A, we are making 6 TVs and 0 wind turbines. But society says we want some wind turbines. We need to have some energy. We need some capital infrastructure investment. So society decides we want to get 1 wind turbine. So society wants to go from point A to point B, which takes it from 0 turbines to 1 turbine. But notice that there's no free lunch. There's trade-offs. Moving from point A to point B certainly gives us our 1 turbine, but that trade-off is going to cost us 1 TV, because at point B we can only do 5 TVs. Okay, so the opportunity cost, that notion, is embedded in the PPF, and it's shown graphically by the slope of the PPF. All right, so we're going to say that the slope of the PPF illustrates opportunity costs. These opportunity costs can be constant, and that would lead to a straight line PPF, or far more common, those opportunity costs can be increasing, which will lead to a bowed out, or if you want to use fancy terminology to justify your big tuition at this place, a concave PPF. Okay, if you take a look right here, you'll see this is just an extension of the PPF. I just added some annotation to it. You will see here, let's open that up a little bit, that as you go from A to B, let me erase that, make it cleaner for you. As you go from A to B, you're gaining here 1 turbine. And as you go from B to C, you're gaining 1 turbine. And as you go from C to D, you're gaining 1 turbine. But look at the trade-off. Look at the opportunity cost. Moving from A to B, this first wind turbine only costs you 1 TD. Your second wind turbine, which takes you from B to C, costs you 2 TDs. And to get your third wind turbine to go from C to D, it's going to cost you 3 TDs. What this implies, my friends, and this ties back to something we talked about in topic 1, this idea of increasing costs. We had said a while back that marginal costs rise over time. The reason is because opportunity costs rise over time. Now, there's lots of technical reasons for this, and we can discuss them when we have live time synchronous lecture. We'll go over some examples, and we'll kind of talk about the mechanics of it. But the basic idea is that opportunity costs increase over time. This is so prevalent that this has been given its own very important and very fancy name, the law of increasing cost. And this tells us that the opportunity cost of producing an additional item will generally increase over time as more of the item is made. Okay? In other words, we're saying that over time, adding additional marginal, we know that term, over time, adding marginal resources to a production process will yield less and less marginal output. So as a result of that, since each additional unit is giving you less additional output, since each marginal resource is giving you less marginal output, the marginal cost of production goes up. And that ties back to what we said back in topic 1 when we did the marginal cost, marginal benefit graph, that marginal costs rise over time. Okay. Briefly, the law of increasing opportunity costs stems from the basic idea that resources are not equally adaptable. There are simply some resources that are really good at some things and not so good at other things. You know, there are some workers that are just really good in some areas and not at other areas. There are some natural resources that are really, really conducive to making one product, but not another product. Since resources are not equally adaptable, as you move resources from their highest value, where they're really good, to their lowest value, in other words, to go back to this example, as you keep making wind turbines and convert TV resources over to that, over time, the resources that are left are not going to be really good at all at making the additional new product. Since they're not equally adaptable to it, since they're not efficient in making it, their productivity will fall. And the flip side of productivity falling is cost rising. Okay, think about that. The flip side of productivity falling is cost rising. Because if every additional unit gives you less and less productivity, then you have to hire more and more and more units to keep your productivity stable. So less productivity means higher marginal, higher opportunity cost. Okay, so at this point now, my friends, we've built up this idea about the PPF, about the law of increasing opportunity cost. I want to talk about one more small part of this model, and then we'll wrap it for the day. Okay, so again, we've talked about the PPF and its illustrative efficiency with points in it, on it, and beyond it. We've talked about the PPF as its illustrated opportunity cost as we move from one point of the PPF curve to another point, and we learned the law of increasing marginal cost. The final big piece, the final big reason why this model is so important in economics is the PPF also illustrates economic growth. We're going to define long-run economic growth as a sustained increase in the quantity of goods and services produced over time. That's kind of a raw, kind of a rough, crude definition, but it gets the job done. Economic growth is an increase, a sustained increase in the productive capacity of an economy over time. And as a result of that, economic growth is illustrated by an outward shift of the PPF. That's why I said before that items that are beyond the PPF are impossible right now. They're unattainable right now. But look at what economic growth does. Economic growth shifts you. We're going to call this one here, the original one, PPF1, and we'll call the new one PPF2. We're always going to label. Economic growth is shown graphically as a shift from PPF1 out to PPF2. Notice what this means. When an economy grows, when the PPF shifts, it means that things that were once impossible and unobtainable are now possible and attainable. The reason why you guys have such a higher standard of living at your age than your parents or even your grandparents did, there's lots of reasons, but the primary reason is because you have been a part of an economy since you were born here that has grown and grown and grown. And each of those economic growths has moved that PPF curve out. Before, the economy could only produce 6 TVs. Now we can produce 8. Before, we could only produce 3 turbines. Now we can make 4. Before, C was at the limit, and I'll make this point right here, point M was impossible. But now that the PPF is shift, C is old news, and M, what was once impossible, is now attainable. Economic growth is powerful. That's why economists are so big on thinking about growth and development, at trying to identify the institutions that make growth possible, at pursuing policies that make growth possible. Economic growth makes everybody's standard of living rise because the economy as a whole is able to produce more. That means that there's more production. If you go back to the circular flow model, that more production leads to more jobs, and everybody wins. The economy grows, and we're all better for it, okay? So that's economic growth, which is manifest by a shift. Given this, let's finalize with one last quick thing, and then I'll give you an example, and then I'll cut it, and you guys will work out that example over the next couple of hours. Given the assumptions of the PPF model, which we learned earlier, let's identify several factors that may contribute to growth. And remember, economic growth is simply a shift outward in the PPF. So if you think about the constraints that bound the original PPF, you can think about the cause of economic growth in that way. So what's going to contribute to economic growth? Number one, most clearly, innovation. Oops, let me erase that, make that cleaner for you. Innovation and new technology. This is why R&D, research and development, why innovation, why entrepreneurs are so critical to a society. Because innovation causes economic growth. Remember, one of our big 3 assumptions early on, PPFs are constrained by existing technology. Well, if you can innovate, if an economy can grow its innovation capacity, its technology capacity, the PPF shifts. Number 2, we can also get growth by improvements in physical capital. We had said earlier in discussing resources, the land, labor, and capital, that capital refers to the machines, the factories, the robots, just like the stuff that makes production possible, okay? If we can improve our physical capital, if we can get better factories, more efficient factories, smarter robots, all these different things, then we're able to convert the same amount of resource into more finished goods. You can think of physical capital as leveraging human capacity and resources. Good machinery, good tools, good factories, good robots, good software allows us to make better use, to get more output from a fixed set of inputs. A third thing that can cause economic growth is improvements in human capital. Whereas physical capital is making our factories and our robots and our machines and our technology better, human capital is making the worker better, okay? Increasing human capital can be achieved by educating. That's why you're maybe here at college. We had said a while back, and I think on our first topic, I had said, why are you in college? And the answer was to make some money. Well, I didn't ask the question then, but I'll ask it now. Why would a college graduate make more money? Just because you have a piece of paper? No. It's because, at least in theory, going to college and pushing yourself and learning to communicate and resolving problems and growing your capacity to think and to solve issues and to collaborate, all of those make you a more productive worker. So improving human capital is a big contributor to economic growth. And again, that can come through things like your education, training, all those different things. The fourth thing that can happen to increase economic growth is an increase in the economy's resource base. Whether that is, in a time of war, taking on new territory, or whether it is having the physical capital to drill and access oil deposits, for example, that weren't accessible before, or if it's something as simple as passing legislation that guarantees everybody the right to work, for example. All of those things are going to increase the amounts of land or labor or capital that an economy has. If you can increase your resource base, you're going to increase your physical productive capacity. This is a very big lesson for some of those countries that still deny, for example, women the right to vote or the right to work or the right to go out, in public. Besides all the human rights issues, there's there's plenty of human rights issues, don't get me wrong, but there's major economic inefficiencies. You're talking about half of your population that you're not allowing to be productive. Those economies will always have really, really low-level PPF curves and will always operate inefficiently because they're keeping one half of this human creativity pent up, okay? And the final thing, we talked about technology, physical capital, human capital, and resource base. The final thing, the fifth thing, and this is a slightly more esoterical, but I want to give it to you, that will increase economic growth would be an improvement in the economy's institutions or in the rules by which the economy is governed. An improvement in either the institutions or in the rules that govern and guide an economy. Any institutional improvements or any rule improvements that strengthen property rights, for example, that strengthen freedoms, that make information more accessible, that reduce the barriers to entry and competition. Any of those things will make existing resources more productive and possibly free up other resources. And all of those, my friends, will make economies grow. Okay? So, pretty big jump we took here. We started off with the PPF and got some basic ideas, and now we've extended that to be thinking about what are some broad things that an economy can do to grow. And we know that since the PPF has its limits, if we push those limits out by improving our technology, improving physical or human capital, acquiring or freeing up resources, or by making the game more efficient by improving the rules and the societal norms and the institutions, we're going to grow. Note that this is also something although they won't, this is also something that our political leaders should be talking about too. You know, they should be talking about how to keep the American economy productive. Because again, Republicans say we want more of this for our people, and maybe Democrats say we want more of that for our people. But look right here, they're missing the point. If our politicians were able to give us more and more and more economic growth, our country could make more and more and more stuff, and both parties would be able to give their constituents more of everything. As it is right now, our politicians tend to play a zero-sum game. I gain, you lose. Economic growth is a win-win, okay? That's about as political as I want to get, but I wanted to bring that up in the context of growth because bad policies can hinder growth just as good policies can push growth, okay? With that said, let me give you an example that I want you to work on, then I'll cut the video, and next time we meet on video, we'll solve this together, but I want you to give it a shot first. Here's an example for you. There is a society composed of one guy, John, right? Clearly a jabroni. No one wants to be around the guy, but what are you going to do? This economy produces only 2 items, nuts and coffee. Given his current resources and technology, so you know there's a PPF coming here, in one given day, John can produce either 24 pounds of coffee or 12 pounds of nuts or some combination of the two. So given the constraint of one day and the available resource and technology base, John can either produce 24 pounds of coffee or 12 pounds of nuts or some combination in the middle. Given that, my friends, I want you to take a few minutes to answer these questions. Question number 1, what does John's PPF curve look like? Question number 2, what are his opportunity costs? And question number 3, can't John just produce 24 pounds of coffee and 12 pounds of nuts? Look back at your notes, at your book reading, at other stuff that you've researched for this idea of trade-off and opportunity cost. Figure those out, and we'll connect again soon. Thanks for your time. Keep your chin up. Work hard. Thank you.